All right, in this video, we're going to look at 2E, so characteristics of distributions of numerical data. So we're looking at shape, location, and spread. And as you can see on the page, we're looking at kind of histograms, but we can look at other graphs as well, or plots, whatever you want to call them. So distributions of numerical variables are characterized by their shape and special features such as center and spread. Okay, so first of all, center and spread. So two distributions are said to differ in center if the values of the variable in one distribution are generally larger than the values of the variable in the other distribution. So consider, for example, the following histograms shown on the same scale. Okay, so here's our scale here from 0 to 15 and 0 to 15 here. Histogram B is identical in shape and width to histogram A, but has moved horizontally several units to the right, indicating that these distributions differ in the location of their centers. Okay, so here you can see the range of values go from, 3 to 11, whereas here it starts at 8 and goes to 16. So even though they're the same shape, their center has changed. Okay, so let's just say this histogram looked at an initial running times maybe, and then over a certain period of time they improved, okay, or marks on a test. So over a certain amount of time after studying, they've improved. So things kind of staying the same, but in reality they probably wouldn't, but let's just say they stay the same, but they've just moved along. So the shape kind of stays the same. So the person at the front stays there, then there's a majority in the middle, and then a few at the end. All right, so histograms C and D below also differ, but not in the same way. So while both are centered at the same place, so you can see here they're kind of centered around just before 10, so between 5 and 10. Histogram D is more spread out, so it has a greater range. So range is just your difference between your smallest value and your largest value. So you can see here this one goes from 1 to 15, whereas this one has a smaller range, or it's less spread out. It goes from 4 to 11. So two distributions are said to differ in spread if the values of the variable in one distribution tend to be more spread out than the values of the variable in the other distribution. I can't talk. Distribution. Okay, so they're differing in spread. This one is further spread out than this one. So an example might be, let's say these were results of students in one maths class. So at year 11, let's say we've got the general, the methods, and the specialist, and the general class took a test, and this was their results. Okay, so quite similar because they're all at about the same level. And here we've got the 3 classes, so it's more spread out. Okay, so yeah, there's many different examples you can think of, but these have similar things in common, or more things in common, and these are more spread. All right, what we also look at is symmetry and skew. So a distribution is said to be symmetric if it forms a mirror image of itself when folded on the middle along a vertical axis. Otherwise, it is said to be skewed. So remember the word symmetrical, the same on both sides. So basically we're symmetrical if we were to cut ourselves down the middle. Okay, we're the same on the left side as on the right side mostly. But things that aren't symmetrical are said to be skewed. Now, a huge thing, not in the scheme of things, but a big problem that students tend to make and don't make this error is they say things are, and I go, oh, I did not mean to do that. That's a problem, huh? Here's a big problem, me changing the page. All right, so I just want to type on here. It's going to let me type. This is a big no-no. You're going to let me write? There we go. Oh, it does it again. Sorry. Okay, got one line on my cross. This is a big no-no. Big no-no. Do not say symmetrically skewed. Okay, what's that called? An oxymoron? Okay, when two things are opposite. Okay, it can't be symmetrically skewed. It's one or the other. Okay, so often on when marking further exams, students will say want to say it's symmetrical, but they're so used to saying skewed, so they say it's symmetrically skewed. Okay, that's just not possible. It's either symmetrical or it's skewed. It's not one or the other. All right, so let's have a look at the difference. So histogram E below is perfectly symmetric, while histogram F shows a distribution that is approximately symmetric. So you can see here it is perfect. So the left-hand side is very similar to the right-hand side, whereas this one here, it does look quite symmetrical, okay, but it's approximately symmetric. So it wouldn't be skewed as such because the left-hand side is pretty much like the right-hand side. Now, if it was skewed, so it wasn't negatively skewed, let's rewind that. If it's not symmetrical, like it is in E and F, sorry, I was just reading as I was talking, it's either positively skewed or negatively skewed. So you can see here we have two histograms that are skewed, and this is important information to have in your bound reference because very often you'll be asked to describe the shape. Okay, so if you're saying it is symmetrical, okay, that's fine, that's easy. If you're saying it's skewed, you have to either say it's positively skewed or negatively skewed. Okay, so histogram G is positively skewed, histogram H is negatively skewed. Now, here's a way I always think about it. Now, it might seem a little bit childish, but in my 14 years of teaching, I've always taught it this way because it's how I remember it. So let's just pretend a little girl, and it's a bit hard to see because there's writing. There she is. She's got nice long hair, but she didn't do it. So it's all over the place. Okay, so she's standing at the top of a slide and she wants to go down that slide. So there's a slide there. Okay, when she goes down, which direction is she going in? She is sliding down in the positive direction. Okay, so this is the positive direction here. Now let's say her friend here, who is standing at the top of another slide, who has nice, neat hair. Now the hair has no difference whether it's skewed or not. She is going down the slide on this side, and she is going in the negative direction. So that's how I always remember it. Someone's just standing on the top of that histogram and sliding down. And in which direction are they sliding? They're either going in the positive direction or they're going in the negative direction. Okay, so that's how you can remember whether it's positively skewed or negatively skewed. Okay, so when you think about this data set though, so getting away from the slide and the girl sliding down in her hairstyle, most of the values are here. Okay, so that's where the majority of the values are for positively skewed. Okay, and we have a few down here. You also need to refer to outliers, but we'll cover them later. And here we have the most of our values and just a few down here. Okay, so it's negatively skewed. So basically, if something is skewed, you say whether it's positively skewed or negatively skewed. So just finishing off this section, knowing whether a distribution is skewed or symmetric is important, as this gives considerable information concerning the choice of appropriate summary statistics, as will be seen in the next section. Okay.